So 6.5, this is an intro to inverse functions. I don't know if you remember or if we've ever found the inverse function of something, but we're going to practice it here. The inverse of an exponential function is a log function. So you've heard when we're solving equations, inverse of exponential is log, and we've used that in solving, but now we're going to talk about graphs. Let's remember some properties of functions that are invertible. First, functions must be 1 to 1 in order for their inverse to exist. Summarize how to determine if a function is 1 to 1 or not. And this is where I come in and help you. Here I go. Here we go. Okay. A function is 1 to 1 if there is one x value for only one y value. Okay, 1 to 1 means for every x value there's only one y value, so there's not double points going up on the y. Okay, consider for a moment this exponential function. Hey, this was on the last test we took. What does a negative in front mean? A negative in front means it's an x-axis reflection. The negative in front of the x means a y-axis reflection, so there's not a y-axis. What does the x plus 3 mean? It's going to be a shift left 3, so it's the opposite, but a plus 2 on the end means up 2. Okay? This function's been graphed here on the right. A table of values has been provided to remind you of the transformation from the parent graph, which was just 2 to the x, into these new points here. All right, so are you considering that? Consider for a moment. Have you considered? Yes? Okay. So to find the inverse of a function, what is done numerically? You may or may not know this, but that's why I'm teaching you. Okay, ready? You're going to switch, S-W-I-T-C-H, switch the domain and range. And what that also means, well, what is the domain? The domain, they're the x values, right? And what's the range? Y values. So to find the inverse function, what we're going to do is we're just going to flip the x's and the y's. The graph of an exponential function has a horizontal asymptote. When the inverse is formed, how do you think this appears in the inverse function? At first I'm like, you guys have no idea how to do this, but maybe we could kind of figure it out, okay? The horizontal asymptote is a horizontal line, so it's usually, like, what's the horizontal asymptote for this one? Okay, so it's 2, but how do we write that as an equation of a line? Y equals 2. Now, if we know the inverse means to switch x's and y's, then this is a y, right? And what am I telling you to do? Switch it. So the inverse, that is not an official symbol for inverse, okay? What would the inverse be? Like, what's going to happen to the horizontal asymptote? It's going to turn into what? X equals 2. What is x equals 2 on a graph? Well, the y equals 2 is a horizontal asymptote. What are we predicting x equals 2? A vertical asymptote. That's just a prediction. We'll see. We'll see what happens, right? Okay. You ready? For the exponential function above, make a table of values for the inverse function, and this is real easy because we already have the points, right? So to find the inverse, what are we going to do? Switch the x's and y's. So we have -5, 1, and 3/4. We're going to switch that. Do you mind? I think it's easier to graph if we have it in decimals, right? So we're going to switch the x and y. What is 1 and 3/4 in decimals? 1.75. And then the y value becomes -5. That's all. What are we doing? Switching them. And that's called what? Inverse. Inverse. Switch the x and the y for each term. Some students, when you have forgotten to put the parentheses, either on domain and range or on coordinate points, and it's wrong if they don't have the parentheses, so make sure you put that. Do you guys see this inverse symbol? Do you see that f to the -1? That means the inverse of f. And if you're like, wait a minute, what the heck is an inverse? That's what we're learning, okay? An inverse is when we switch the x and y's. Ready? We're going to graph these points on here, and we'll see what it looks like. So 1.75 and then down 5. Are we good? Okay, let's keep going. 1.5 down 4. 1 to the right, down 3. Left or right 0, down 2. And then we're going to go left 2, down 1. Left 6, up or down 0. Cute, okay. And here we go. I feel like I did something wrong. We're gonna pause. Let's connect these points and make a beautiful exponential. Oh, what did we predict was gonna happen? So let's go back up here. Up here we had a horizontal asymptote at y equals 2. But then to find the inverse, we switch the x's and y's. So we switch a y from y equals 2, and we predicted we would have something at x equals 2. Now let's look at our graph. What do you notice at x equals 2? Do you see how the points aren't going to hit 2? So we have a little vertical asymptote here. I don't know why I said that. Vertical asymptote at x equals 2. Page 1 in the books. Turn the page. All right, now let's find the equation of the inverse of x. Remember, but you may not remember, to analytically find the inverse, what do we do to the equation? So again, what did we do on the front side? We switched the x's and y's. Guess what? That's what we're going to do again. We're going to switch x and y. After you do that, you solve equation for y, but I need to write the word for y, and then replace y with the notation for inverse. So we're going to replace y with f to the -1, which means inverse. Perform the process you just described to the exponential equation to find the equation of the inverse function f to the -1 of x. So every time we see f of x, that's really just y. But what we need to do is we need to switch the x and y. So I'm going to go over here and we'll say x equals -2y plus 3, and then plus 2 is down below. Not below, but on the same level. So check step 1, switch the x and the y. Solve the equation for y. So here we are, there's a y up here, and we need to isolate the y. So what do we do first? Subtract this 2. If I use different colors, do you like that? Subtract the 2. So we have x minus 2 equals -2 to the y plus 3. Now the goal is to isolate the base, and our base is 2. Now I don't know if you remember from the previous unit, can the base be negative? No, so this is really a -1 in front of the 2. So up until now in your algebra life, you'd think that this is -2 and it's by itself, but not quite in this unit, okay? In this unit, we need to move that -2 to the other side. Another random fact is that the next step is going to be take logarithms, and we can't take the logarithm of a negative, right? That's why we say our base can't be negative. So this is really like a -1 that we need to move to the other side. How do we move a negative to the other side? You know, it's division or multiplication. It all means the same thing. When in regards to 1. So our x is negative, and then we have negative x plus 2 equals our base 2 to the y plus 3. Here we go. You ready? How do we bring this y plus 3 downstairs if we have a base 2? We're going to take the log base 2 of both sides. So this log base 2 of all of the right side, there you go. And then right here we'll take log base 2 of this. And that will cancel. So I'm out of room. Let's see. Log base 2 of negative x plus 2 equals y plus 3. What's our goal? Do you remember? Solve for y. Okay, y equals log base 2 of negative x plus 2, and then we have a minus 3 on the end. Is y by itself? Okay, so what does number 3 say to do? Replace y with the inverse function notation. And that's it. That's what though? What is that? That is the equation of this graph. Okay? So we did it numerically by switching the numbers, and we got this curve. So this is a logarithmic graph where we just spent 4 weeks in exponential. So a log is the inverse of an exponential. Numerically, graphically, and we just found the equation. All right, so we're going to practice that with these 3 examples. We'll see how many we can do before time runs out at 15 minutes. You ready? Here we go. So step 1, switch the x and the y. Switch the x and y. Next step, switch. The next step would be to isolate base. Isotate. That's my day. Isolate the base, okay? So we're going to add 3. Now, how do we bring that exponent down? We're going to do the log of both sides. What base are we going to use? Isolate base. Log base 2 of both sides. So on the left we have log base 2 of x plus 3. And on the right the log base 2 cancels the 2. And we just get that. Okay, then what? We got to get y by itself. Solve for y. So we have a negative y plus 3. So 2 steps. We're going to subtract 3 and then divide by -1. So we have log base 2 of x plus 3 minus 3 equals -y. And then divide by -1. And the final step would be to change the y to an f to the -1. Okay, watch how I'm going to write this super pretty. -3, what's -3 divided by -1? 3. And then in front of the log, that's a positive, but it's divided by a negative. So we're going to say minus log base 2 of x plus 3. Okay, I want you to try these, and we'll go over these in class tomorrow. Thanks for watching.